Hello, my name is Emer Keaveney. I'm a marine mammal ecologist with Orca Ireland and a PhD student at the University of Ulster. And today I'm delighted to present bubble net tool use in humpback whales foraging off the Irish coast in collaboration with Ocean Alliance and Sound Science Research Collective. With the onset of recent advances in novel technology, such as unmanned aerial vehicles or drones, becoming more readily available and affordable, they are being increasingly used in marine mammal studies for behavioural sampling. Offering a unique bird's eye view allows us to examine behaviours in more detail than we were previously capable of. Humpback whales are known to exhibit a range of foraging behaviours, and among the more complex manoeuvres to increase prey capture include the use of bubble net tools. Bubble net feeding involves either a group of humpback whales or a solitary individual expelling air underwater to form a vertical cylindrical ring or cloud of bubbles to corral and stun small schooling prey species. Bubble netting whales have been described not only exclusively in humpbacks from the Gulf of Maine, Massachusetts and Frederick Sound in southeast Alaska, but more recently have also been described in other parts of the world, such as Australia and the Antarctic. While bubble netting behaviour is more commonly described for group feeding whales, it is also employed by individual animals. Here we quantitatively analysed the first documented aerial evidence of bubble net feeding behaviour in a humpback whale in Irish waters. We analysed the structure of bubble netting behaviour of an individual whale off the south coast of Ireland, with examples of confirmed bubble netting behaviour in two other populations known to engage in this technique. In doing so, we demonstrate behavioural similarity between allopatric populations and confirm shared foraging techniques among individuals that lack geographic overlap. Every clip that was analysed was annotated, and variables that were measured included duration and type of lunges, the number of individual whales, the orientation of a whale before a dive, and the number of revolutions and turning rate in degrees per second. Unpaired t-tests were used to test for significance between group size and lunge duration, and group size and lunge type. Our results indicated that the most frequently employed prey capture technique during bubble net feeding was found to be vertical lunge feeding in both individual and group feeding bubble netters across allopatric populations in different geographic locations. Group feeding bubble netters had significantly longer lunges, an average of 2.78 seconds, compared to individual bubble netters, which had an average of 1.37 seconds. In conclusion, in the summer of 2020, using unmanned aerial vehicles, UAVs, or more commonly known as drones, bubble netting behaviour was documented in a solitary humpback whale foraging off the southwest coast of Ireland for the first time, providing an opportunity for comparison of the mechanics of this behaviour with aerial footage captured in the Gulf of Maine, Massachusetts Bay in 2020 and at Frederick Sound, southeast Alaska in 2016 and 2017. Documenting the spread of well-described behaviours in new populations of humpback whales provokes further investigation into the social learning and foraging plasticity in this species and to test further hypotheses about the drivers of behavioural change. Thank you so much for tuning in and listening. I would also like to thank my co-authors and the eco-tour operators Bantry Bay Charters who made the study possible.